In this tutorial, I'll take you through everything you need to know about getting started with OrcaSlicer. This is a complete beginner's guide designed to give you a solid foundation so that you can start slicing and printing with confidence. Whether you're brand new to 3D printing or switching over to OrcaSlicer for the first time, this tutorial will walk you through the essentials step by step. So let's get started. Oh, and if you haven't already, make sure you subscribe so you don't miss the rest of this series. I've got a ton more content lined up to help you get the most out of your printer. Before we get started, here's a quick breakdown of what we'll be covering. Navigating the menu and settings, I'll walk you through the OrcaSlicer interface so you know exactly where everything is. The OrcaSlicer tabs, you'll learn all the different slicing tabs including the Prepare, Preview, and Device tab. The Control toolbar, we'll go over the essential tools for adjusting and fine-tuning your model before slicing. Slicing and G-code basics, understanding what happens behind the scenes when you hit the slice button. And the filament and process menu settings, optimizing your profiles for different materials, ensuring smooth, reliable prints. I've also organized everything into chapters in the timeline so you can easily skip ahead to any section that you need. Before we dive in, I wanted to mention that I'm currently running OrcaSlicer 2.3.0. If you're watching this video at a later time and things look different, that's probably why. OrcaSlicer is constantly evolving with new updates and improvements, so it's always a good idea to check for the latest version. Now let's take a quick tour of the interface to get you familiar where everything is. We'll go into more detail later, but I just want to highlight the key areas first. Right here in the center is the view pane, which is the main workspace where all your models will be displayed. Every time you load in a model into OrcaSlicer, this is going to be where it appears. Just above that is the toolbar, which gives you full control over how your model interacts with the workspace. You can move, scale, rotate, resize, cut, and modify your models right from here. It's also where you're going to import and add your models, making it an essential part of the workflow. Over on the left-hand side of the screen is the settings panel, which is broken down into three main sections. The printer settings. The printer settings section lets you configure your printer and make sure that all your correct profiles are selected. Below that, the filament settings allows you to control your filament profiles, adjust temperatures, and select the type of material you're going to be working with. And finally, the process settings. This is where you fine-tune print details, layer height, infill supports, and more. At the top left, you'll see the mode menu, which includes different working modes. The Home tab is your starting dashboard, while Prepare is where you set up your model before slicing. Preview allows you to analyze your slice model before printing. And Device is where you manage your printer's connection settings. There's also a project mode that gives you more information about the current project that you're working with. And finally, at the very top of the screen, we have the main menu where you'll find all the program's core settings, preferences, and additional tools. Now that you have a general idea of how everything is laid out, let's start breaking down each section in more detail. Before we dive in, I would like to give a quick shout out to today's sponsor, Elegoo. Elegoo has been making some serious moves lately, especially with the launch of their new Centauri Carbon. It's a Core XY machine loaded with features, and it comes in at just $299. Honestly, I've got one myself, and it's currently my #1 choice. Super fast, super reliable, and a blast to use. They've also got the Neptune 4 series, perfect for solid FDM printing, and their resin printers are some of the best in their class. Plus, they offer a full line of high-quality filaments that deliver consistent results. Links to all the Elegoo products down below. If you enjoy my content, please consider supporting the brands that support me. Now that we've covered the basics of the interface, let's dive into the main menu and break down all the settings and options available. Starting with the File menu, this is your standard software file management system, where you can start a new project, open an existing project, or even view recent projects. If you work on a lot of different prints, you can even customize how many recent projects are displayed in this menu. I'll show you how to adjust that in just a bit. You also have the option to save your project, save as, and import files. The import function allows you to bring in not just 3D models, but also OrcaSlicer settings, which can be really useful when you're working with a custom profile or downloading pre-configured settings from the community. Next up is the export menu, which offers several different ways to save your work. You can export your workspace as an STL file, which is the standard file format for 3D printing. If you're new to 3D printing, STL stands for stereolithography, a format that's been around since 1987 and still widely used today. However, there's a newer format that's gaining popularity, the 3MF file, which stands for 3D manufacturing format. Unlike STL files, 3MF files store additional information such as custom supports, variable layer heights, and even color data, making them a more versatile option. Because of this, I highly recommend saving your files as a 3MF whenever possible to preserve all your print settings. Other options in the export menu include exporting pre-sliced plates, which saves your model as a grouped print job, export G-code, which is the actual set of instructions your printer will follow, Export preset bundles. This will allow you to export printer config files, filaments, and presets. And of course, at the very bottom, you'll find the quit option to exit the program. Next, we have the drop-down menu, which doesn't have a name, but it contains several useful functions. Inside, you'll find the edit menu, which includes standard options like undo, redo, cut, copy, paste, delete selected, delete all, clone selected, duplicate current plate, select all, and deselect all. Next, there is the view menu, which controls how you see your model within the slicer. You can quickly switch between different perspectives, including top, bottom, front, rear, left, right, and perspective and orthogonal views. Learning the shortcuts for these will save you a lot of time, especially when you're working with complex models or fine-tuning your print orientation. Before we move forward, let's take a moment to talk about the two different view modes in OrcaSlicer, perspective and orthogonal. Understanding the difference between these two modes will make it much easier to position and align your models correctly, so let's break it down. In perspective view, objects appear slightly distorted based on their position in 3D space. Think of it like an FPS game. Things closer to you appear larger, while things further away shrink into the distance. This can sometimes make it difficult to judge whether a model is properly aligned with the build plate or overlapping with another object. On the other hand, orthogonal view removes this distortion and gives you an accurate to scale representation of your model. The term orthographic literally means perpendicular projection, meaning every part of your 3D object is displayed with a perspective skew, as if it were projected onto a 2D plane. To better illustrate this, let's take a look at this helmet model real quick. In perspective view, the front face of this model looks like it's sticking out past the edge of the build plate, suggesting that it might not fit or we won't be able to slice it or print it. However, when I switch to orthogonal view, you can clearly see that the model is actually fully within the build plate, and the perspective distortion was simply making it look incorrect. Once I switched to orthogonal view, I've never looked back. So my recommendation, set your view to orthogonal right from the start. It'll save you a ton of frustration, making working with your models much easier. The auto perspective view is a very new feature and a bit advanced for new users. But in short, it changes your view from perspective to orthogonal view when changing your view pane to the different views: front, left, right, and top. Just note that this feature is here to explore once you get more comfortable with the software. The Show 3D Navigator just allows you to remove the view cube right down here in the view pane. I think it's useful, so I always leave this on. Next is a feature that I've used once before and it was a lifesaver. But for whatever reason, the left side menu disappeared. I have no idea what happened, it was just gone. After 10 minutes of poking around the settings, I finally hit this reset window layout button and it was back. I am guessing that this can happen from time to time, so this feature was added. So if you ever have an odd issue with your windows disappearing, remember this feature. Alright, let's move on. Next is our Show Labels feature. I use this feature kind of religiously when I have a bunch of models open. This will allow you to quickly see which model is which. This is especially helpful when printing multiple models on multiple build plates all at once. It definitely has its use here. You can see when I move multiple models onto one build plate, I can quickly see the names of each models. And can you imagine if I have 50 models open with 36 build plates? This feature becomes a huge time saver. The Show Overhang feature will highlight the sections of your models that may need supports. Turn this on if you would like to see a portion of your model highlighted. I usually allow the slicer to add supports for my overhangs. It does a great job, so I never turn this feature on. The Show Selected option just adds a white outline around your model. I feel the default box highlighted is good enough, so again, I leave this feature off. Feel free to experiment with them and see what works best for you. Alright, now let's dive into the preference menu. I'll touch on most of the important settings here, but for the most part, the default configurations work just fine. At the very top, you'll find the options menu for language, location, and measurement units. Unless you have a specific need to change them, I recommend keeping these units set to metrics since most 3D printing standards follow this system. Next, you can set the default page that OrcaSlicer starts at. I recommend changing this to the Prepare tab. This is where you're going to be 99% of the time. Camera style has two options, default and touchpad. If you're using a touchpad on a laptop, this feature will help when moving your camera around. I would never recommend using OrcaSlicer with a touchpad, but maybe some people do. Next is an option called Allow Only One OrcaSlicer Instance. This one is definitely getting unchecked for me. I almost always have multiple 3MF files open at once, so I need the flexibility to work into several projects at the same time. If you enable this setting, it will limit you to only one open instance for OrcaSlicer. The only reason I would suggest keeping this checked is if you're using a low-end PC and want to conserve system resources. The zoom to mouse position option is entirely personal preference. When enabled, zooming in and out will focus on wherever the mouse pointer is at. I've tried it both ways and honestly, either works fine. I would recommend trying them both and seeing which one feels more natural to you. The use free camera option is something I definitely do not recommend. If enabling this option, the camera will rotate around freely rather than keeping it constrained to an object that you have selected. I definitely do not recommend using this option. The reverse mouse zoom option will just reverse how you zoom in and out in the prepare window. Normally, when zooming into an object, you roll your mouse wheel forward, but with this option checked, it will zoom out. Definitely an uncheck for me. If you don't want to display the startup splash screen, you can disable it by checking this option. I always leave tip of the day checked, you never know what you might learn. For flushing volume, auto calculate should be left checked. This setting calculates the amount of filament required for each color change and will automatically update the values when you swap out colors. The multi-device management should be checked and turned on to enable this feature. If you have more than one printer, you may find this useful. The auto arrange plate after cloning is a new feature. It basically will initiate the auto arrange function after cloning an object. Again, this is just a preference. Just realize that this feature exists so you know where to find it if you want to disable it. Flushing volumes auto calculate every time a filament color change is happening. This feature you want turned on and does all the work for you automatically. Auto sync user presets will sync any of your presets from other slicer software such as Bambu Studio. I leave this checked. I also leave update built-in presets automatically. If OrcaSlicer decides to make changes, then it will automatically update for me. Remember, printer configuration is also checked. I would recommend leaving it that way. I always leave both checked for stable updates and enable network plugin checked. The stealth mode can be enabled for users that don't want to use Bambu printers, and it prevents data from being transmitted to the Bambu cloud. This is a feature for users that only want to use LAN mode for printing. Under associate files, I recommend leaving these checked unless you primarily use another slicing software and don't want your 3D files to automatically open with OrcaSlicer. Associate web links to OrcaSlicer allows web links of models to open OrcaSlicer automatically when clicking on them. For the maximum recent project settings, I like to increase this to 25. By default, it's set to 18. But I tend to work with a lot of different models and files, so bumping it up allows me to quickly access more of my recent projects. Now, I definitely recommend keeping no warnings when loading 3MF files with modified G-codes unchecked. This is an important safeguard because some 3MF files can contain modified G-code, which could potentially be harmful to your printer. Leaving this setting off ensures that you get a warning before running anything that might cause some issues. Another must-have setting is the auto backup. This one should always be enabled. If your computer is slow, you can consider increasing the backup interval to reduce how many times it saves, but I would never recommend disabling it entirely. The downloads folder can be left at the default setting unless you prefer saving your slice files to a specific location. And of course, dark mode, I always turn this on. It's easier on the eyes, especially when you spend a lot of time working in front of the screen. And as you can see, I already have it turned on. Leave both developer mode and skip AMS blacklist unchecked. Alright, that wraps up the preference menu. Once you've customized these settings to fit your needs, you're all set and ready to move on. Okay, let's quickly go through the help menu just to familiarize ourselves. The keyboard shortcuts give you a list of all the shortcuts in the software. This is definitely useful. I am a total nerd when it comes to shortcuts and saving time. I would definitely recommend spending a few minutes at least quickly looking through all the different shortcuts, as I found a few that were very helpful. Most of these will be more clear once we get through the gist of the software though. The setup wizard will take you through the initial steps when you first launch the software. The show configuration folder will basically open OrcaSlicer config folder and display it on the screen. The show tip of the day is useful and I always leave this on. If you click this button here, it will open up the tip of the day. Now the last options are pretty straightforward. I don't think we need to spend any time on them. And next, I think these three icons are pretty straightforward. The disk is going to save your project, and these two arrow buttons are for undo and redo. I would recommend using the shortcuts Ctrl-Z for undo and Ctrl-Y for redo. This calibration button is a more advanced feature and we'll go over that in another video. Now before we move forward, I wanted to bring something to your attention. Since OrcaSlicer caters to many different 3D printing manufacturers, you are going to see anomalies with the interface throughout this tutorial. These slight differences will be noticeable depending upon which type of printer you have currently selected in the left menu. Let me show you a quick example of this. Currently I have my Elegoo Centauri Carbon printer selected. For the different mode tabs here at the top, I have the house icon, prepare, preview, device, and project. Now if I change to my Bambu Lab A1, you can immediately see the multi-device and calibration modes appear. Since Bambu Lab has integrated the multi-device system and a custom calibration page into their Bambu Studio software, it has been brought over to Orca Slicer. Now I am not a software developer, but I can imagine that. Since both Orca and Bambu Studio use similar code bases, That is why we are seeing it in Orca. Anyways, all that I wanted you to take from this is that there will be anomalies in the Orca Slicer interface depending upon which printer you have active. All right, let's quickly talk about the different modes here at the top. We have the house icon, which is the home tab. Prepare, which is where you can do all your model preparation and settings. The preview tab is where you'll view all your models. Once it is sliced and ready to print, it will display all your printer's G-code layer by layer. More on this later. The device tab is like your central command. You can switch to each connected printer, view the current print, and control the printer directly from here. The project tab will display the current open model information, such as who created the model and any information that the creator included with their model file. All right, let's go ahead and discuss these tabs in more detail. The house icon is our home menu. Currently, I'm logged into my MakerWorld account, which is linked to Bambu Cloud. You can start a new project with this button here, open a project, or view and open any recent projects in this section here. There isn't really a whole lot to do here. That is why I recommend changing the default page to the Prepare tab. So let's go ahead and move over to the Prepare tab window now. This is where you'll be spending most of your time in OrcaSlicer. This is where all the magic happens. Scaling, rotating, cutting, painting, and of course, slicing your models to get ready for printing. Before we dive into all the tools, let's go over how to navigate the view pane. If you hold down the middle mouse button or right click, you can pan your view around. Left clicking and dragging will rotate and orbit your view. One thing to note, your camera will always rotate around the current selected build plate, which will be important when working with multiple plates. Scrolling with the mouse wheel will zoom in and out, making it easy to focus on different parts of your model. Now when clicking on a model, you will notice a white boundary box appears around it, and the toolbar at the top will activate. This means that the model is selected and ready for editing. At this point, left-clicking and dragging the model will allow you to move it freely on and off the build plate. This is just the basics of navigation, but getting comfortable with these controls will make working with OrcaSlicer much smoother. Next, let's take a look at the toolbar and how to start modifying your prints. The first icon is where you can import a model straight into your project. Remember a few minutes ago when we can import models using the Import button in the File menu? Well, this icon does the same thing. Next, let's talk about the Add Plate button. A feature that really comes in handy, especially when you're planning multiple prints or working with large projects. Currently, you can have up to 36 plates open at once, which is great if you want to stage multiple prints ahead of time. Personally, I work with large prints, so I almost always have more than one build plate active in my view pane. Now, when you import a model into OrcaSlicer, it's not always positioned in the best way for printing. You'll likely need to make some adjustments. For this example, I've loaded in a small pot from a model creator named Delta Prints. I'll also include a link to all the models and creators I use in this tutorial. As you can see, both the pot and the tray are sitting outside of the print area. Obviously, we can't send this to the printer like this, so let's split it into two separate prints. First, let's add a new build plate from the toolbar. Now that we have a second plate, we can move the tray onto it, keeping each model organized for separate prints. Now let's make sure both models are properly centered onto their own plates. To do this, right-click on the model to bring up the menu. But before I hit center, I want to point something out. OrcaSlicer will center the model to whichever build plate is currently active. The active plate is always highlighted in darker gray. Watch what happens when I try to center the tray with the wrong plate selected. It's going to center to the wrong build plate. So always double check which plate is active before making adjustments. Alright, now let me undo that. Select the correct plate and recenter it properly. Keeping your build plates organized like this makes it much easier to manage multi-part prints and streamline your workflow. Next up, let's talk about the Auto Orient feature in the toolbar. I use this occasionally when I want to import a bunch of models onto the build plates, but don't have the time to manually adjust each one. It's a quick way to let OrcaSlicer position your prints for better stability and print orientation. Let me show you how it works using this pot model. First, I'm going to rotate this model just a little bit. Let's pretend it was imported like this by default. Now, instead of manually adjusting it, I can use the Auto Orient tool. Make sure your model is selected, then hit the Auto Orient button. As you can see, it instantly flips the model back onto the flattest, most stable surface. Now, while this tool is useful, I don't always recommend relying on it 100%. Sometimes a slicer may not position a model exactly how you prefer, especially for more complex prints. But in situations where you need a quick fix, it's a real time saver. Now let's take this a step further. Let's say you have multiple models on your build plate. For this example, I placed 6 random succulent pots in different orientations. Instead of adjusting each one manually, I can select them all at once. Just hold down Shift and drag a box around all of them to select them. Then hit Auto Orient. As you can see, it instantly aligns all of them correctly. Super handy when working with batches of parts. Now moving on to the next feature, the Arrange All Objects button. I'll be honest, I don't use this feature a lot because I typically print large models, so I rarely have more than 1 or 2 models on my build plate at a time. But if you're printing multiple small objects, this can be a great way to quickly organize them for the best efficiency. There are 2 places where you can arrange objects. First, there's a button next to each build plate, which arranges just the models in that specific plate. The second option is in the Toolbar menu. Clicking the Arrange All Objects toolbar button will bring up a drop-down menu with more options. The spacing option will set the spacing distance between the models after being arranged. Just note that if you set the spacing to 0, OrcaSlicer will auto-select a spacing that it sees fit. You can check the auto rotate for arrangement if you want to allow OrcaSlicer to rotate your models for more time saving. I will show you how this will affect your prints in just a minute. Allow multiple materials on the same plate will keep models that are set to different print materials on the same plate. Just be warned that this will drastically change the time of print. I always leave this feature unchecked and print all my same materials together. Now the align to y-axis is one of those features that at first glance is hard to understand. Here's my definition. Aligning the y-axis can decrease the time it takes to print depending on the model's geometry or the number of models on the build plate. It also optimizes the toolpath creation in some instances. Please note that you need to check your model slice, that it does not always mean that it will be faster. It can actually be slower in certain circumstances. I personally do not use this feature. I have tested it with many different projects and it's a hit and miss feature for me. Next, let's take a look at the auto rotate for arrangement option and see how that works. When enabled, OrcaSlicer will automatically rotate and arrange objects on the plate to minimize travel time, which is the distance the extruder has to move between each print area. Reducing this distance can help cut down on print times and increase efficiency. To see this in action, let's try an example with 3 small pot models. First, I'll move them really close together and then slice the plate. The total print time is estimated at 5 hours and 51 minutes and a total travel time of 1 hour and 20 minutes, or about 22.7%. Now if we spread these models apart, placing them on separate corners of the build plate, we can slice it again and check the difference. Now the total print time has increased to 5 hours and 53 minutes with a total travel time of 1 hour and 22 minutes, or 23.2%. Now if you want to see a visualization of the travel time, just check this box right here and you'll see all the extruder movement paths during the printing. It's a really useful way to understand how your printer moves between objects. Lastly, let's quickly try the auto arrange feature right next to the build plate. Simply select your active plate, then hit the auto arrange. This applies the previous set auto arrangement settings to the active plate, automatically organizing everything in the optimized layout. It's a handy tool when you don't want to manually adjust placement, but you still want an efficient setup. Alright, now that we've covered the auto rotate and auto arrange, let's move on to the next tools in the OrcaSlicer toolbar. For this, I'll use this cute little knitted dino model from 3D Prints. To activate the move tool, click on your model first. Then click on the move button, or press M on the keyboard. Next, you're shown 3 different arrows coming from the center of the model. The blue arrow is the Z-axis, the green arrow is the Y-axis, and the red arrow is the X-axis. Now if you hover over each of these arrows, you'll see a number. That is the current distance of the center of the model from the bottom corner of the build plate. These numbers correlate with the blue, green, and red set of arrows right here. If I quickly change all of these values in the move fields to 0, the model will center itself with the bottom left of the build plate. Now notice that if you type in a value or pull the blue arrow, the model snaps back down to the build plate. Your model will always lay flat on the build plate. To exit out of the move function, just click anywhere in the view pane off of your model. The rotate button works very similar to the move button, as it has the same 3 axes, X, Y, and Z. But now of course we're going to be working with rotation rather than position. Click on your model and click on the rotate icon or hit R on the keyboard. You can either rotate your model by typing in a specific angle in the box above, or freehand by pulling on either of the arrows on each side of the box. Now I want to show you how to use the snap feature. This is going to make your model snap to a predefined angle when dragging one of the arrows. 2 sections with white lines will appear. If you keep your mouse within the ring of the lines, it will snap to those lines, 5 degrees at a time. The inner circle of the lines will change the rotation by 45 degrees. Again, the model will always snap to the Z-axis to ensure that it's making contact with the build plate. The last thing I wanted to mention is the reset button. If you click this orange circle arrow, it's going to zero out your model rotation. Next up is the scale button. First, click on your model and click on the scale button here or hit S on the keyboard. This is similar to how the move and rotate buttons work. You can type in a specific value or scale your models by a percentage or by a specific millimeter size. If you want to scale it without being uniform, simply uncheck this box. Now, freehand scaling is similar. You just grab one of the boxes and pull on it. The blue, red, and green boxes will scale your model without being uniform. I'll pull on the blue box, and as you can see, it's stretching my model along the Z-axis. Once I let go of my mouse, it will show you the new scale values in the boxes above. If you want to scale your model uniformly, then you would just use the light blue boxes. Just click and drag. If you want to reset your model back to the original size, just hit the orange circle button right here and you're back. The Lay on Face tool is something that I use quite often, especially when printing large dinosaur skulls with dozens of models. Now, the way this tool works is it will allow you to quickly place a model on any side directly onto the build plate. When deciding how you want to print something, there are often times when you import a model and it's not positioned correctly. One of the main goals is to get as much flat surface area onto the build plate for maximum adhesion. Now, we could quickly use the Auto Orient tool, and most of the time OrcaSlicer will give you exactly what you need, but sometimes it needs a little more manual work. Let's first select our model, then right up here in the toolbar is the Lay on Face tool. Once you click on that, you'll be shown a bunch of round white shapes all around the outside of your model. These white surfaces represent the side you'll lay your model on. If you click on one of these, the model will rotate and lay flat on that surface. Let me quickly rotate our model on its side to demonstrate how this works. As you can see, the flattest surface is on the bottom, and I would like to lay it flat on this surface. If I activate the Lay on Face tool again, then click on the white surface area on the bottom of the model, it will rotate and lay flat on it. Like I mentioned before, you can always try the Auto Orient tool first. If that doesn't give you what you need, then just remember the Lay on Face tool. The cut tool is one of those tools that I use when I want to print a model larger than my build plate. The cut tool in OrcaSlicer does a fine job at getting it done. Let's take this cute dinosaur model for an example. Well, I could use the cut tool to slice a dino in half, click on the model, hit C on the keyboard, and you're presented with a window with some options. There are two modes, planar and dovetail. The planar basically is a flat, straight surface cut, and the dovetail creates a dovetail-like cut on your model. For now, let's use the planar mode. You will also notice that there are now two colors, turquoise and purple. These represent the two parts that you'll get after you perform your cut. They help with color coding your options in this section right here. What this does is tell you that the turquoise cut part will be kept and not discarded if you check this box. It will then place the part onto the cut after you perform a cut. Or you can select the flip option here and it will flip it upside down after you perform the cut. Just below that, there are the same options for the purple cut section of the model. Now, if you click this Cut to Parts checkbox right here, what it will do after it performs the cut is it won't move the model at all, but it will separate your model into two separate parts, which you can see under the Objects menu. Let me show you that real quick. Alright, let me undo this real quick so that I can show you how to control your cut. Using this icon with the circle and 4 arrows will allow you to move your cut up and down, moving the circle just like this. And to rotate it, you can use the arrows here and here, just like the rotate tool. It also has the inner and outer rings to allow you to snap your plane to a specific angle. The next feature for the planar cut mode is the ability to set your cut height to a specific millimeter Z distance. Type in your amount here to move your cut planar. Just under that is the Add Connectors button. Once you click on the top portion of your model, it will disappear and a new set of options will show up. This is where you can manually place connectors for your model. This will give you a way of connecting your model back together once it's printed. This is a bit on the advanced side, so I'm going to skip it for this tutorial. Just know that this feature exists, and I would check it out and give it some experimenting to find out the style that suits you best. Great, let's move on to the next cut mode, which is the dovetail. This option works pretty much the same as the planar, except we have additional options that control your dovetail cut. You can adjust the depth, width, flap angle, and groove angle. You can also see that there are more options for adjusting the position of your dovetail cut on the model. I almost always use the dovetail option when cutting a model. It allows for a much stronger connection between two models when gluing them back together. However, if you don't plan to do any post-processing, then a dovetail may not be your best option. It does create more cut lines on your model, so just keep that in mind. I'm not going to go into too much more detail about the cut tool. I think you have the basics for now. It's just one of those features that I suggest you experiment with on your own. But I will be creating a more in-depth video of the cut tool, so keep an eye out for that. Next, I'm going to skip over the support and seam painting, and we'll be talking about that a little bit later. Let's go ahead and open up the Emboss tool, or the text tool as I call it. For this tool, you don't actually have to have a model selected to open it, unless you want to place text onto a model. For example, if you were trying to make a sign or something. Let's go ahead and add a primitive square first. Right-click on the build plate, click on Add Primitive, then Cube. Next, let's resize it a bit. Now I'm going to click on the object and hit T on the keyboard to open up the text tool. Next, let's switch over to the objects mode so that we can see both our resized cube and the text. You can see both right here. Now if the text tool closed on you, all you have to do is click on the embossed text object and then click the text tool toolbar icon right here. First, to change your text, all you need to do is change it right here. Next, you can change the font to whatever you like. It's going to take your font styles from your installed system fonts. Now it's a little hard to see. Your text might be the same color as your object. Let's fix that. Just add a second filament right here. Assign it a color, then click on the Emboss Text tool again, and hit 2 on the keyboard to change the color. Alright, that's much easier to see now. I get this question asked a lot on how to adjust text on your models, so knowing the process of using the Objects menu, selecting your text object, and then opening the text tool is really a good tip to know. Anyways, let's go ahead and move on. Adjusting the height is basically changing the font size, and the depth is how thick you'd like your font to be. You can rotate your text using the box and arrow icon here, just like the rotate tool. Also, if you want to move your text around, just click on it and drag it around. The advanced options add a lot more control over your text. If you click on the Use Surface option, it will not allow your font to protrude outside the object's surface. So if I check this box and use the Rotate feature here, you will see that the font gets cut off on the edges. Now if I uncheck the Use Surface option, then it will no longer get cut off by the object's surface. To demonstrate the per glyph option, let me add a primitive cone and some new text. Now let me adjust the text to look a little bit better real quick. Okay, so first if I click the Use Surface feature, the text gets stretched out around the sides. But if I use the per glyph option with the Use Surface, it fixes that. It also adds a transparent ring to show you the path of your text. This is useful and I'll show you how. First off, you can see how the text doesn't really follow the roundness of the cone along the bottom. Let's fix that. If I hit R on the keyboard to open up the Rotate tool, I can rotate it forward. You will notice that it starts to cut into the cone model. Switch back to the text tool now and uncheck per glyph and recheck it. Now you can see that the path of the text better follows the cone. I'm pretty sure this is just a workaround that I discovered, but for now it works. Alright, let's move on. The Align tool just aligns multiple lines of text how you want. Go up to the text box, hit enter, and add your second line of text. Character gap, line gap, boldness, and skew all adjust the text, with letter spacing, line spacing, boldness, and skewing your text. From surface, this is how high up from the build plate your text is, and I already showed you the rotate tool. The set text to face camera feature is silly, and I honestly have not ever used it, and it seems like one of those features that would never get used. Next, you can adjust the style of the font using the drop-down menu here. And last, under the operation is Join, Cut, and Modifier. Join leaves the font as a separate object, just how it already is by default. Cut will turn the font into a negative part, meaning it will actually cut out an area that it touches another model. So if you wanted to put some text onto a surface that is cut out, then you would use the Cut option here. Next, let's go ahead and check out the Measure tool. While this tool is a great added feature in OrcaSlicer, it will definitely leave you with much to be desired. Let me add a primitive cube to the work plane and show you the basics. Right-click on the work plane, add primitive, then cube. The way the measuring tool works is first you select either an edge or a plane on your object. Let's check the distance from one edge to the other. Once your mouse gets close to the edge, the cylinder shape will show up along the edge. Okay, you have your first measuring reference point. You can see up here in the menu, it says edge and gives you the length of that edge. Next, let's do the same thing for the opposite edge of the cube. Great, the measurement shows us that the distance is 25.7 millimeters across the cube. You can also manually change the size of the distance by hitting this edit icon here and inputting a new amount. Now, if you needed to backtrack your measurements, let's say you clicked the wrong edge or something, hit escape once on the keyboard will basically go back one measurement. Hit it a second time, you'll go back and undo again. And the third time, you'll completely exit out of the measurement tool. While we're here, let's go ahead and duplicate our cube so we can go one step further. Make sure your cube is selected and press Ctrl-C, then Ctrl-V to paste it. Great, now we have two cubes. Let's go ahead and move them apart from each other and give them some distance. Now that we have two cubes, what if we wanted to take a measurement of the distance between them? Seems simple enough, right? Well, it's not exactly, but I'll show you how we can accomplish this. First, select one of the cubes, then open up the measurement tool. You will immediately notice that the second cube is gone. This is because the measurement tool only works with the currently selected objects. Let's go ahead and back out of the measuring tool real quick by hitting the escape on the keyboard or clicking on the measuring tool icon here in the toolbar. Now, since we want to take measurements between two objects, let's first select both cubes. You can do this by selecting your first object, then holding down Control on the keyboard and clicking on your second object. A larger white boundary box should now be displayed around both objects. Great, now open up the measurement tool by hitting the U on the keyboard. Now you should see both objects in the view pane with the measuring menu open. If you want to get the distance between the two cubes, you can first do it by selecting a plane or surface on the left cube, then the plane on the right cube. Now the measuring tool should be displaying the distance between the two planes. The last thing that I would like to show you is that you can also measure angles. First select one plane on your cube, then the plane directly next to it. Of course, we know this is going to be 90 degrees, but this becomes more useful when you're working with complex models. Alright, that wraps up the measuring tool. It's not packed full of features, but I'm sure additional functionality will be added to OrcaSlicer when it updates. Now the Assemble tool is one of my favorites. As I mentioned before, I love to print large models. This means that I get all kinds of models from different creators, and sometimes they split up models that could easily be printed together on my printer. Many creators are still using smaller than 256mm build plates, so rather than printing them separately, I can use the Assemble tool to join them together and print them as one part. That means less glue, less post-processing. Let me show you how this works. As a very simple example, let's take our two cubes. Let's go ahead and select both for this. I will use the Shift on the keyboard and drag a selection box around them. This is another way of selecting multiple objects at once. It's a much quicker way if you have 20 models on the build plate and you need to select them all. You can also use the Control-A as well, but that will select every model in your project, but sometimes that isn't what you want. With both cubes selected, right-click on one of them and click Assemble. Now what that does is put them into a group. You can see that by clicking on the Objects button right here. You have an assembly with two cubes inside it. Oh, and by the way, you can also rename anything in this list. Select the object that you want to rename and then click on it once more, just like this. Next, let's go ahead and select the cube assembly, then open up the assembly tool by clicking on it in the toolbar. There are two modes which determine how you will assemble your two models together: face-to-face or point-to-point. I tend to use the face-to-face most of the time, so let's quickly see how that works. First, decide on the two surfaces that you want to assemble together. Click the first one on the left cube and then click the surface on the right cube. Once you have them selected, a new menu will pop up. It will immediately give you the distance of how far apart the two surfaces are. The Flip by Face option will flip the second object by 180 degrees for you. Not quite sure why you would need to do that, but as a tip, I would definitely recommend lining up your two parts with the Move and Rotate tool beforehand. Now you can manually decrease the distance by typing in a number in this box right here. This is useful to check the two parts to see if they're lined up correctly. Also, if you need to rotate an object to match, you can set the rotation in this field right here. If you're doing all your aligning beforehand, you won't need to use this feature, but it's there if you need it. Now to assemble the two parts, just click on the Center Coincidence button. Now your two models are assembled together. Let me undo that so that we can see how the point-to-point works. If you switch to the point-to-point mode, it is very similar. It basically allows you to choose a point on your models to assemble them together. Let me show you real quick. Now that I have the 2 points selected, instead of a button that allows me to assemble them together, You can specify the distance in the X, Y, and Z fields here. Changing them all to 0 will assemble the two cubes perfectly together. Alright, that's the basics of assembling two models together. Let's go ahead and move on to the very useful tool, the Brim ears. Brim ears are small extra pieces added to the corners of your 3D print. They help the print stick better to the build plate, especially on sharp corners that might lift off the build plate. Think of them like little helpers that hold your print down, so it doesn't peel off while printing. After printing, Brim ears are super easy to remove. The first thing we need to do is make sure that we allow the Brim ears to print while adding them to the slicer. To do that, we need to head over to the Others tab and change the Brim type to Painted. Next, click on your model that you want to add Brim ears to. I'm going to stick with the two primitive cubes that we have been working with to make this demonstration easy. Once you click on your models, it'll activate the toolbar above. You can either switch to the Brim ears by hitting L on the keyboard or clicking on this icon right here. You'll see the Brim ear menu pop up. Let's quickly go over each of these features. Head diameter is going to be the size of the circular pad that is laid down along the edge of your model. The higher the number, like 20, the larger the ear. It also means you'll get more coverage around each corner of your model. The next feature is the max angle. Now this works with the auto generate points feature. You can set your maximum angle here, and when you use the auto generate feature, any angles that are above the maximum angle threshold will generate a Brim ear. I personally like the auto generate feature as it makes my workflow much quicker, and I trust the slicer to find areas that need more assistance than I would. Plus, the last thing I want to do is hand lay Brim ears on 150 different parts. I'm talking about a recent project, my life-size Triceratops, that I recently finished. If you're interested in printing any model at any size, I'm currently working on a 5-foot long Triceratops print. I'm just about done with the video, and it teaches you everything step by step. It took over 70 rolls of filament, and it's absolutely massive, so keep your eye out for that video. The next feature is the detection radius, which also uses the auto generate option as well. This feature is built around the Raymer-Douglas-Peaker algorithm. If you want the short answer, the lower the detection radius number, the higher amount of Brim ears that will be generated. The section view feature works exactly as it does in the painting feature. It will remove sections of your model from the top down. This is great when placing down a large model like I do with a peg hole in the middle. It makes it easy to find those corners and place down your Brim ears. Also, if you press down on the control button on the keyboard and use your mouse wheel, it will adjust the section view without having to use the widget slider. To place down your Brim ears, it's quite simple. Using the mouse, just freely move along the model. You don't have to be at the base of the model against the build plate either. Just click and the Brim ear will be placed flat onto the build plate against the model. The first time I opened this feature, I was trying to place them along the build plate, but quickly realized that that wasn't needed. Next, you can remove all your Brim ears with this button here, or if you select a Brim ear by clicking on it, it will highlight and you can use this button here to remove individual ones that are placed. Oh, and the last thing that I wanted to mention, once you leave the Brim ear feature, you won't be able to see them in the Prepare tab. You have to slice your model and view them in the Preview tab only. Alright, that wraps up most of the tools in the toolbar. Next, let's dive into the left-hand settings menu. This is where you can control everything about your print's quality, speed, supports, and more. This panel is broken down into 3 sections: printer, filament, and process. Each of these sections play a crucial role in fine-tuning your prints. But before we dive into the details, I want to show you a quick interface trick that will make navigating this menu even easier. If you click on the word printer or filament, you can collapse these sections, giving you more space to work with your process settings below. This is especially helpful when you're adjusting fine details in the process section and you don't want to see any of the other settings at the moment. Alright, let's break down each section and what it controls. Below the printer section, you'll find where you can add 3D printers that you own. This is where you can manage all your printer profiles, and it's super easy to set up. Now see this double switch icon? Clicking that brings up a menu with dozens of preset printer systems from many different manufacturers, making it really simple to add a new machine. Let's go ahead and add a new printer from Elegoo. Let's scroll down the list until we hit the Elegoo section. I'm going to go ahead and add the Neptune 4 Max with a 0.8mm nozzle. What this is doing is adding all the information from the Neptune 4 Max printer having a 0.8mm nozzle, and it's going to include those presets down into our process menu. If you're not sure the difference in nozzle sizes, most printers come with a 0.4mm nozzle, which is pretty standard. The 0.4mm nozzle can handle pretty much every kind of print. Now, if you're looking at printing small figurines for a tabletop game, then you would want to purchase and install a 0.2mm nozzle, as it will give you a much higher quality print for those small details. On the flip side, if you plan to print large models such as a full-size dinosaur skull or statues, then you would want a larger nozzle such as a 0.8 millimeter nozzle. As you can see here under the huge Elegoo Orange Storm Giga that has a 1000 by 1000 millimeter build plate, that they offer a huge 1.0 millimeter nozzle to make those large prints finish quicker. I hope that all this makes sense. So back up to the Neptune 4 Max, I'm adding a 0.8 millimeter nozzle and all I do is hit confirm to add it. Once it is complete, you can see that the printer preset with a 0.4 millimeter nozzle and a 0.8 millimeter nozzle to pick from. Obviously, you need to physically install the 0.8 millimeter nozzle into your machine to use that 0.8 millimeter nozzle preset. If you ever need to remove a printer preset, just click on the drop-down menu again, click on the Select/Remove option. The preset menu will open back up. Find the printer that you want to remove, uncheck it, and then hit confirm. Now you can see my Neptune Max with a 0.8 millimeter nozzle is now gone. Next to the printer drop-down menu, you'll see another small edit icon. Clicking on it lets you tweak your printer presets, but most of the settings here are locked unless you're in the advanced mode. Honestly, unless you know exactly what you're doing, I'd leave this section alone until you're very comfortable with making adjustments. For this beginner tutorial, we're going to stick with the preset options and keep things simple. Next, if you click on the text bed type, it will bring up the OrcaSlicer wiki page. This has a lot of great information that you should refer to if you ever run into an issue. The drop-down menu will allow you to change one of the different build plate types. If you ever run into an issue with the bed type grayed out, I'll show you how to fix that right now. Currently, my Neptune 4 Max is only showing a smooth high temp plate. Well, this is not the bed type that I have for my Max. I use the textured PEI plate. So the way to fix this is to go into the printer settings by clicking the edit button right here. Right on the first screen, under the basic information, you will see an option, Support Multi-Bed Types. As you can see, mine is unchecked. If you check that, you will notice that a star was added to the front of the name right here. That means that settings have been changed and not been saved to your printer yet. So to fix that, let's hit the disk icon to save this change. A new window will pop up and is trying to add the word copy. This is because OrcaSlicer is preventing you from making an adjustment to the settings of the system preset. Let's remove the word copy and just add bed type. This will tell us that we modified our printer preset and added the multi-bed type feature. Click OK. And as you can see, the star is now gone. Great, let's close this window. Next, let's make sure that the user preset we just created is selected. Click on the drop-down menu. You will now see that there is a Neptune Max system preset and our Neptune Max user preset. If you click the user preset, the bed type is now changeable. Let's go ahead and change to the textured PEI plate. While we're here, let's go ahead and talk about different bed types. There's a smooth cool plate, engineering plate, smooth high temp plate, and textured PEI plates and textured cool plates. 98% of the time, I use the textured PEI plate. I rarely have any issues with my print sticking to this plate, so I really don't use anything else. Some of the other plates can give you some cool textures or transfer holographic designs to your prints, so if that interests you, I would suggest taking a look at some of the plates available on Amazon, and I'll add a link below. Next up is the filament section. The great news is that with version 2.3 of OrcaSlicer, it has all been drastically improved. First up is our Add One Filament button. If you click that, it will add another drop-down filament below. This is something that you would use if you had an AMS from Bambu or an Ace Pro from Anycubic. There are many multicolor systems from many different manufacturers. Once you add a second filament, the ability to remove filaments will appear right here. You may have also noticed that the flushing volumes button has just appeared as well. If you click on that, you'll be presented with some options, so let's quickly go through that. Since we have two filaments added to our machine, this menu displays all the calculated filament amounts that it will take to purge from your machine before switching to another color. The columns going down are the from filament amounts, and the rows going to the right are the to filament amounts. Obviously, with only two colors, we're seeing some zeros here. Once this is filled up with 3 or more colors, you'll see a lot more amounts. The multiplier field below allows you to make adjustments to all these amounts on the fly using a multiplier. Just be aware that adjusting it too low will cause bleeding into other colors. This is a more advanced feature, so I'm not going to go into it with too much detail, but just be aware that this menu exists. It's basically for managing your color change filament amounts. Alright, let's go ahead and click cancel and go back. Clicking this double switch button right here will bring up a menu with 2 tabs. System filaments and custom filaments. The custom filaments is where you can add any type of filament that you can't find in the system filaments section. With the latest update of OrcaSlicer 2.3, they made it much easier for filament manufacturers to add their filament profiles to the software. This makes it a game changer for everyone. The reason you would add a custom filament would be so that 1, it would be in your system to use, and 2, it will allow you to calibrate it to get a better print result. I have a few brands that I've used over and over, so I have set up my own filament and calibrated them. We won't go into that into too much detail as it's another advanced feature, and honestly, it's not even needed at first. What we will do right now is go into the system filament section and scroll down so that we can see the horizontal scroll bar and browse through all the different filaments. For now, I'm going to select the generic PETG and hit confirm. The window will close. Next, let me show you where that filament is at now. If you click on the drop-down menu right here, you can see it is now included under the system presets. I have used the generic system preset for thousands of hours of printing and have gotten super clean prints from my machines. While that actually works most of the time, you may want to take your generic filament to that next level and calibrate it. I will also be posting a video on how you can do that soon. Another way to access the filaments window is by hitting the Add Remove Filament option in the drop-down menu. For now, let's go ahead and change our filament one to the generic preset. Next, let's see how we can adjust the filament settings. Click on this edit icon right here. Once the material settings window opens up, you'll see a lot of options. You have your basic info here. This is where you can adjust the nozzle temp. There are options to adjust the chamber and bed temperatures as well. The Cool tab allows you to control the fans on your machine, of course, if they're available. Enclosed printers will have the chamber and exhaust fans. Just be aware that this is here. The settings overrides section is where you can adjust retraction. This will be done if you're noticing inconsistencies in your printing like stringing or uneven prints. Once you make adjustments, the name of the filament will have a star in front of it. You will also see that these orange circle icons will show up. Clicking the icon here will reverse any settings you made on any of the tabs, while the orange circle icon next to the feature will only undo that particular feature. Once you're satisfied with your settings, you can save your filament by clicking on this disk icon here. It will ask you for a name. I usually will include abbreviations of the changes that I made to the name at the end. Next, you have the option to save this custom preset to be used for all projects by clicking the User Preset option, or if you only want it to be used for this particular project, you would click the Preset Inside Project option. Hit OK to save and hit X to close the window. Navigating back to the filament dropdowns will reveal your new custom preset filament with your changes. Awesome, let's go ahead and move on to the process menu. The first thing that we're going to talk about is the Global and Objects toggle button. When Global is highlighted in green, any changes you make to this tab will apply to the entire project. But if you switch over to Objects, that means you're now working with the settings for the individual models in your project. Now you'll notice an Advanced toggle button. This unlocks a bunch of extra settings, but since this is a beginner's guide, we're not going to dive into that just yet. I'll be covering all the advanced features in a future video, so stay tuned for that. But for now, just know that these extra settings aren't necessary to get started with 3D printing. Next up is the View All Object menu. This is where you'll see a full list of every model that you've loaded into your project. It's a quick and easy way to get a bird's eye view of the settings applied to each model. This is super useful because if something looks off, you can catch it at a glance instead of clicking through each model individually. You can also make adjustments here if you need. Let's change the filament for this model right here. I'll show you a quick shortcut. If I click on the filament color, you get a drop down of all the different filaments. A quicker way is to just click on the filament color, and to switch it to the number 2 filament, just hit 2 on the keyboard. You can also make changes to each of these columns. Click on the settings number and make your adjustment. It will also bring up more settings that can be adjusted. Super quick and easy way to manage your prints, and like I mentioned before, spot anomalies with specific models that have different settings that you may want to change. This will become more apparent to you when you start printing large files with 10 to 20 build plates at once. Just keep this feature in mind. Right next to View All Objects, we've got the Compare Presets feature. This lets you load 2 different presets side by side to compare their settings. Think of it like an online shopping comparison tool. It lays out all the details so you can easily spot the differences. This is great if you're testing out different print profiles and if you want to see exactly what's changing between them. I've always liked this feature. Let's go ahead and talk about presets. Before we move on, let's switch to the Centauri Carbon printer. This printer has a save preset that I created. The drop down right here is going to be the menu of all the process presets. As you can see, I have one set up specifically for the Triceratops model. Now if I switch to my P1S real quick, You can see that there are a ton more here. I have presets that I have saved for my droid prints, some of my dinosaur skull prints, and even some of them with variations of print quality. I wanted to make sure that you understood that these presets are specific to each printer type. Now I have two P1Ss, so these presets work for both of those. If I switch back to the Centauri Carbon, you can see there are two sections: system presets that are set up by default with OrcaSlicer, and the user preset that I created specifically for my Triceratops project. Think of these system presets as a solid starting point, kind of like a foundation for building your own custom profiles. As you gain more experience with 3D printing, you'll start to tweak these presets to better suit your specific needs. Eventually, you'll find settings that not only improve your print quality, but also save valuable time and filament. Once you're comfortable, diving into the advanced mode will open up even more possibilities. You'll discover that small adjustments can make a big difference, whether it's optimizing speed, refining support structures, or fine-tuning extrusion settings. But for now, I highly recommend sticking with the system presets. They're well tested and designed to give you consistent results right out of the gate. One important tip: if you ever run into a print failure or notice declining quality, don't hesitate to revert back to the system preset. When I first started creating my own user presets, I eventually drifted so far away from the original settings that my prints started to fail outright. Resetting back to the system preset quickly got me back on track, and I was able to troubleshoot from there. So always keep that in mind when experimenting with custom settings. Let's take a closer look at system presets and how they relate to nozzle size. If you check out the system presets for this particular printer with a 0.4mm nozzle, you'll notice that the available layer height range is from 0.28mm down to 0.12mm. This range is optimized for a balance of speed and detail when using a standard 0.4mm nozzle. Now let's say we add another Centauri printer, but this time we're going to add a 0.2mm nozzle. You'll see that the range of layer heights shifts from a 0.14mm down to a 0.08mm. That's because smaller nozzles can produce finer details, but at the cost of slower print speeds. So it's important to keep in mind that each nozzle size has its own layer height limitations. The general rule is simple: the smaller the layer height, the higher the detail, but the longer the print time. If you're printing highly detailed miniatures or intricate parts, a 0.2mm nozzle might be a great choice. But if you're printing large models like vases, statues, or even full-size dinosaur skulls, a larger nozzle such as a 0.8mm will dramatically speed up your prints without worrying as much about fine details. It all comes down to what you're printing and how much detail you actually need. Let's go ahead and move on to the process tabs below. In the process section, you'll see different categories like quality, strength, support, multi-material, and others. Before diving into each setting, I want to highlight something that makes OrcaSlicer really user-friendly. When you hover over certain titles, you'll notice that they highlight. This means that they are linked directly to the Orca wiki. If you ever find yourself unsure about a setting, you can click on it to pull up more detailed information straight from the wiki. Another helpful feature is how OrcaSlicer visually tracks any changes you make. If you modify a setting, the value will turn orange, indicating that it has been adjusted from the system preset. This is a great way to spot any changes you've made. If you ever need to revert back to the original preset value, just hit the orange circular arrow icon next to the setting and it will reset. This makes it super easy to experiment with different settings without losing track of what you changed. Alright, first up, let's talk about the layer height section. Layer height refers to the thickness of each layer in your print. The smaller the number, the better the print quality. But keep in mind, this also means significantly larger print times. Your nozzle size will determine the range of layer heights you can use, so always make sure you're staying within the range for optimal results. Now, while layer height affects the entire print, you'll notice the quality difference most on angled and sloped surfaces rather than on flat walls. If you're aiming for the best possible print quality, I highly recommend checking out my variable layer height tutorials after this video. It's a game changer when it comes to balancing detail and print speed. The first layer height is another important setting to note. It's always set equal to or larger than your standard layer height, because this helps ensure stronger bed adhesion. One of the most common issues with 3D printing is bed adhesion problems. If you've ever browsed Facebook groups, you've probably seen a ton of people asking for help with first layer adhesion. A thicker first layer helps compensate for any small imperfections in the build plate or slightly inconsistencies in the bed leveling. Speaking of bed leveling, I can't stress enough how much time I spent troubleshooting this issue on my older printers. If you've ever struggled with getting that perfect first layer, you're not alone. It's one of the most frequent pain points in 3D printing. But thank you to all the recent advancements in 3D printing, most newer models will handle bed leveling as a core feature. Next up is seam position, an important setting that controls where the printer starts and stops each layer. As the printer lays down a layer of filament, it eventually needs to return to the starting point to complete the loop. When it moves up to the next layer, the connection point creates a visible seam in your print. This seam position setting gives you control over where that seam appears. The nearest option places the seam as close as possible to the last position of the previous layer. This results in a scattered seam across the model, which can make it look uneven or rough, especially on curved surfaces. The default option, aligned, attempts to place all seams in the same vertical line, keeping them consistent from layer to layer. But it also prioritizes hiding seams in less noticeable areas such as corners or sharp edges. If you're printing an object with angular features like the geometric bowl from Delta Prints, you'll notice that the slicer tries to tuck the seams along one of these edges to minimize its visibility. The next option is back. It's important to note that it refers to the back of the build plate, not necessarily the back of your model. If we slice our object with this setting enabled, the seam will be positioned along the backside of the print. If I rotate the model in the Prepare window and slice it again, the seam will now appear in a different location based on the model's orientation. This is a great choice if you want to control where the seam is placed. Just point the model's preferred hidden side toward the back of the build plate, and you're good to go. Lastly, we have the random option. Instead of having a single visible seam, the slicer distributes the seam points all over the model. In theory, this should make this less noticeable, but in practice, it can sometimes make the surface of your print look messy, especially on smooth or highly detailed parts. Choosing the right seam depends on your model and the right finish you're aiming for. If your print has corners or hidden edges, aligned is usually the best option. If you're working with a model where seam placement isn't a big deal, nearest or random might be fine. And if you have a very specific preference, back gives you full control over its placement. Alternatively, there's another great way to control how the seams appear on your model, and that's by using the seam painting tool. This feature lets you manually paint seams exactly where you want them, giving you complete control over their placement. To use this, first select your model, then open the seam painting tool from the toolbar or pressing P on the keyboard. Before we start painting, let's first change our seam position from random to aligned to ensure a more predictable result. Once the seam painting tool is open, you'll see a drop-down menu with two brush types. The circle brush acts like a traditional brush tool, allowing you to paint your seam in a flat circular area. The sphere brush applies the seams in a more rounded, three-dimensional area, which can be useful for curved surfaces. You can also adjust the brush size for more precision when painting seams onto detailed models. Let's go ahead and paint a seam down the back of our polymetric bowl to see how this works. After slicing, you'll now see the seam has been placed exactly where I painted it, following my crooked line. This is a great way to manually place seams in corners, creases, or other areas where they may be less noticeable. Most of the time, the aligned option does a good job of hiding seams automatically, but for models where precision matters, seam painting is a fantastic tool. I would also like to mention that the section view cuts away your model from the angle of the camera. And lastly, hitting Erase All Painting clears any seams you have painted. The precise wall helps your 3D prints come out the right size and look cleaner. Normally, when the printer lays down two walls next to each other, they squish together a little. This can make the outer wall get pushed out, which makes the print slightly too big or a little messy. Precise Wall fixes this by adding tiny spaces between the inside and the outside walls. That way the outer wall stays where it's supposed to, and your prints turn out more accurate and neat. Precise Wall can improve the final look and fit. For most prints, you can leave this setting off, but if you need that extra precision on small details, sharp edges, or curved surfaces, turning it on can make a noticeable difference. Only one wall on top surfaces. This feature helps optimize the topmost layers of your print by reducing the number of perimeter walls on flat horizontal surfaces. Normally, when a 3D printer prints the top layers of an object, it still follows the same wall settings as the rest of the print, which can sometimes waste material and increase print time without adding much strength. With this option enabled, OrcaSlicer will print only one outer perimeter wall on the very top layers, instead of multiple walls. This can be helpful when printing large, flat objects or models that don't require extra wall strength on the topmost surface. However, if your model needs a stronger, more uniform top layer, it's better to leave this option turned off. Only one wall on first layer. This setting works in a similar way but applies to the first layer of your print. Normally, the slicer follows the usual wall settings for the first layer, meaning multiple walls are printed, even though the base of the print doesn't always need them. By enabling this feature, OrcaSlicer will print only one single outer wall on the first layer. This can help with bed adhesion, reduce material usage, and speed up the initial stages of printing. However, if you're printing a model that requires extra strength at the base, like a structural part or something that might experience stress, it's best to leave this setting off. All right, let's go ahead and move on to the next tab, which is strength. The first setting in here is wall loops, also known as perimeters or shells. These are the outermost layers that form the walls of your 3D printed model. It begins by outlining the shape, creating these loops before filling in the inside. So why do wall loops matter? First, they add strength and durability. The more wall loops you have, the stronger your print will be, making it more resistant to cracking or breaking. Second, they improve surface quality. Extra walls help smooth out rough surfaces and minimize visible layer lines, giving your model a cleaner, more polished look. And third, they increase dimensional accuracy. More walls create a more precise and rigid structure, which is especially important for functional parts that need to fit together perfectly. Now, how many should we use? For small models like a simple cube or decorative print, 2 walls is usually plenty. But if you're printing something larger or more durable, like a full-size dinosaur skull, I always go with at least 4 loops, and recently I switched to 6. I've switched to 6 walls because when you hold the same part, one with 4 walls and one with 6 walls, the 6 wall part feels much more rigid just by upping the wall loops by 2. Ultimately, this setting comes down to what you're printing and how strong it needs to be. If you're ever unsure, just remember, more walls means more strength, but they also use more filament and increase print time. So find that balance that works best for your project. Now let's talk about the top and bottom shells. These are the surfaces that form the top and bottom layers of your 3D printed model. One key setting here is the surface patterns, which determine how these layers are printed. By default, OrcaSlicer uses the monotronic line pattern, but there are several others to choose from. Each pattern has its strengths, and the right one depends on what you're printing and what matters most: strength, aesthetics, or even print speed. If you're printing something purely for looks, you'll want a pattern that provides the best surface finish. But if you're making functional parts, you'll need a pattern that adds extra durability. Just keep in mind, some patterns take longer to print and use more filament than others. Let's quickly go over the different pattern options and when you might want to use them. The monotronic line creates a smooth, consistent finish by adjusting print direction between layers. Great for aesthetic prints where surface quality matters. Keeps all lines moving in the same direction, producing an ultra smooth surface. Perfect for parts that need a premium, polished look. Concentric forms a curved pattern that follows the shape of the model. Best for circular, organic designs or decorative prints. Rectilinear uses a basic grid pattern that balances strength and speed, ideal for general purpose prints. Aligned rectilinear, similar to rectilinear but with an improved layer alignment for added strength. Great for functional parts that need reinforced top layers. The Hilbert curve creates a highly detailed space-filling pattern, best for decorative parts that need uniform surface detail. Archimedean chords forms a spiral-like pattern with balanced strength, best for parts with a central focal point or artistic elements. Octagram spiral produces a star-shaped pattern that evenly distributes force across the surface, great for decorative prints that need a stronger center. The best way to find the right infill pattern is through experimentation. Every print has a different need, so testing a few options will help you figure out what works best. If surface quality is your top priority, monotronic line or Hilbert curve will give you a clean and polished look. If strength is what you're after, aligned rectilinear provides solid reinforcement. And if you're going for a unique visual effect, concentric or Archimedean chords can add some really cool aesthetics to your prints. There's no one-size-fits-all answer. Just keep testing and adjusting to match the needs of each project. Now let's move on to top and bottom shell layers and thickness settings. These directly impact the number of top walls your model prints, which can make a big difference in surface quality. If you're printing something with a lot of fine detail on the top surface, increasing the top shell layers can help preserve those details. A perfect example of this is when I was printing a Star Destroyer model. The intricate paneling and tiny surface details weren't coming out as sharp as I wanted. After troubleshooting, I realized that when my model was transitioning from infill to top layers, I wasn't giving it enough material to work with. Once I increased the top shell layer count, those details became much more clear. Now there's another option here called top shell thickness, which is measured in millimeters rather than layer count. This setting overrides the top shell layer setting. If you ever need a top or bottom layer to be a specific thickness, this is the setting you want to use. For most prints, sticking with the default values works fine, but if you ever notice thin or incomplete top surfaces, increasing either the top shell layers or top shell thickness can make a big difference. Sparse infill density is one of the most important settings that can directly affect your print strength, weight, and material usage. In OrcaSlicer, you'll have two main options to adjust: density percentage and infill pattern. Instead of making your entire model solid, sparse infill partially fills your interior with a structured pattern, leaving intentional gaps between the printed lines. This significantly reduces material usage and print time while still providing enough support for most prints. It's a smart way to save filament and speed up your prints without sacrificing too much strength. When deciding on which density to use for your prints, it's often a matter of preference. If you ever asked 10 people what they would use for a specific print, you would probably get 10 different answers. For more structural prints, I choose 25 to 40%. And for objects that are more aesthetic, I use between 10 and 20%. When printing simple toys or models, 10% infill is usually more than enough. Now, there's a lot of controversy around which infill pattern is the best, but the truth is, it depends entirely on the project. Choosing the best infill pattern for your 3D print depends on specific needs of your part. Strength, print time, material usage, and the intended function all play a role. If you're looking for maximum strength and durability, patterns like honeycomb and gyroid are ideal. They offer excellent strength to weight ratios and balance stress in all directions, making them perfect for high-stress mechanical parts. If you need a balance between strength and efficiency, rectilinear and grid patterns provide decent strength while reducing print time and material usage. Triangles and cubic patterns also offer a good mix of strength and speed, making them great for functional parts that need extreme durability. For prints where surface finish and flexibility are a priority, concentric and zigzag patterns are excellent choices, adapting well to curved shapes while maintaining a smooth outer surface. Some unique patterns like 3D honeycomb and octagram spiral offer specialized benefits such as superior strength while remaining lightweight, making them ideal for decorative or artistic prints. At the end of the day, there's no wrong pattern to choose that will completely ruin your print. The key is to understand what your model needs and select an infill pattern that best supports that function. Keep these general guidelines in mind the next time you slice your model. Take a second to think about whether you need strength, speed, or efficiency and choose accordingly. Alright, let's move on to the internal solid infill pattern. This setting plays a huge role in the strength and durability and reliability of your 3D printed parts. If you're printing something that needs to handle stress or mechanical force, this is where OrcaSlicer ensures structural integrity. Now, instead of just telling you how it works, let's take a layer by layer look at this Lola model by Mystery Makers. When I scroll through the slice layers, you'll notice that the internal solid infill appearing in purple. This is how OrcaSlicer reinforces each print. It's built into the design to ensure every layer is supported, making sure that your final print is as strong as possible. So whether you're printing functional parts, load-bearing components, or just want a more durable print, this setting plays a key role in overall print reliability. Alright, let's go ahead and move on to the support tab. Now the first thing that you need to do is enable your supports, and that's going to activate all the features below. You will also notice that I added two models, a 3D Benchy model and a Man Ray model by Delta Prints. By the way, you can quickly add a Benchy with the right-click menu. Just right-click, then add handy models, then 3D Benchy. We will be using that in just a bit. Let's go ahead and hit slice on our Man Ray model now that we have supports enabled and see what happens. This is going to generate normal supports because that's the type that we have selected here. As you can see in our window up here, the supports are going to take up 40% of the print time with 114 grams of filament usage. Now let's go ahead and change our supports to Tree Auto and slice our model again and see what happens. The tree supports are going to take up 38% of the print time with 46 grams of filament. That's a savings of 68 grams of filament. Now let's take a moment to talk about support structures and why they matter. Supports play a crucial role in 3D printing by preventing overhanging sections of your model from collapsing during the print process. Now there are two primary types of supports, normal supports and tree supports, each with their own advantages depending on the model you're printing. Normal supports, sometimes referred to as linear or grid supports, are a more traditional option. These structures are built in a simple up and down grid pattern, providing direct support under overhangs, making them a great choice for models with basic shapes or moderate overhangs. If you're just starting out, normal supports are a reliable option because they're predictable and straightforward to work with in post-processing. Tree supports, on the other hand, take a more advanced approach. Instead of a grid structure, tree supports resemble the branches of a tree, growing from a single trunk on the print bed and extending outward to support the overhangs. This design minimizes the amount of material used and reduces the contact with the model, making removal much easier while lowering the risk of damaging the print. Tree supports are especially useful for highly detailed or complex models with multiple overhangs, where traditional supports might be a little too bulky or difficult to remove cleanly. Choosing the right support type depends on your print. If you're working with a simple design, normal supports will get the job done efficiently. But if you're printing something more intricate, with lots of detail, tree supports might be a better option to reduce material usage and cleanup time. I really hope that this explanation gives you a clear understanding of the differences between normal supports and tree supports. With this knowledge, you'll have a much easier time deciding which type of supports will work best for your model. If you're ever unsure, the best approach is to just test both options in the slicer, just like I did. Sometimes the best choice becomes obvious as you experiment. And over time, making these decisions will start to feel like second nature. Now let's talk about fine-tuning your support settings. One key adjustment is the threshold angle, which determines which angle the supports will be generated. Right now it's set to 30 degrees, meaning anything below that angle won't require support. But if we increase it to 45 degrees and slice again, you can see that more of the model, like these sections of the manta ray right here, will have supports generated. In most cases, 30 degrees is a solid starting point. But if you notice that certain parts of your model are struggling due to overhangs, adjusting this setting can help ensure a successful print. Now let's talk about the threshold overlap, a setting that controls how much of an overhang extends past the previous layer before generating supports. Unlike the threshold angle, which is based on degrees, this setting works with percentage, or millimeters, to determine when an overhang needs support. To enable the threshold overlap, set the threshold angle to 0. A higher threshold overlap allows steeper overhangs to print without supports, reducing material use. A lower threshold overlap triggers supports, helping prevent sagging or failed prints. For example, if your model has a curved overhang, increasing this value lets more of it print unsupported, saving filament. But if you notice sagging, lowering the setting will ensure proper support where needed. It's a great way to fine-tune your support structures while keeping prints efficient. The on build plate only option in OrcaSlicer ensures that supports are generated only from the build plate, rather than attaching to other parts of the model. This can be useful when you want to minimize contact points on detailed prints or reduce post-processing cleanup. To demonstrate, let's take a look at our Benji model. First, I'll reset our threshold angle, overlap, and supports back to their default values by clicking the orange reset icon. Then I'll reslice the model. If you check the preview, you'll notice that supports are being generated inside the boat deck, connecting directly to the model instead of the build plate. Now let's turn on build plate only and reslice. You'll see that the internal supports are now gone, and only supports that are originating from the build plate remain. This setting is great for keeping your model cleaner and avoiding difficult to remove supports in tight spaces. However, just keep in mind that some of the overhangs may still need additional support depending on the model's design. Before moving on, let me turn this feature off and change supports back to tree supports. Alright, let's go ahead and talk about manual supports. This will allow you to manually paint areas of your model where you prefer to have supports, similar to how the seam painting feature works. In the Prepare tab again, make sure you have your model selected. Next, click on the Support Painting button in the toolbar or hit the L button on the keyboard. In the drop-down menu, you'll see a familiar circle and sphere option. You will also get fill and gap fill options as well. Let's quickly go over some of these. If you select the circle tool and left-click on your model, you can paint a green area on your model. This is telling OrcaSlicer that you would like to have supports generated in this area. Now, if you right-click on your model and paint, it will show up in red. This is telling OrcaSlicer where you do not want to have supports added. These are referred to as support blockers. This left and right-click feature works the same for the sphere and fill tool as well. Next, if we select the fill tool button and hover over our model, you'll notice areas begin to highlight. These are the areas where the fill tool will color in either supports or support blockers, depending on if you left-click or right-click. This makes it easy to quickly fill in areas without having to manually paint the entire surface. Let's test it out by clicking the circular window on the bow of the boat. You will notice that the top half of the window is now highlighted in green. The blocker works exactly the same. If I right-click on the area, it will now turn red and supports will no longer be generated in this area. We can also fine-tune these fill areas. Let's turn on this On Overhangs Only option. When this option is checked, you can only paint supports in areas that are highlighted by Orca. You can also adjust the highlighted areas using the below slider options. Let's first uncheck the On Overhangs Only option. The Smart Fill angle allows you to adjust the overhang angle that you would like to highlight. Holding down the control button and rolling your mouse wheel can be used to adjust this slider. You can lower the angle, and all your highlighted areas will only highlight for that particular angle and below. Let me show you real quick. If I zoom into the front circular window on the bow of the boat, and if I set our Smart Fill angle to something like 70 and click to paint the window, we will get almost the entire boat painted with supports. Now let me erase that. And if I adjust our fill angle down to 20, you can now see that there is much more precision with my support painting. Now let me erase that once more, and if I adjust this to something very low to something like 4, now our bow window overhang has been broken up into many different sections, and they can all be filled in individually. So you can see that this can make it really easy to pinpoint those overhangs and make your support painting much easier. The highlight overhangs is going to automatically adjust the highlight of the model on the fly. This allows you to quickly see which angles may be an issue on your model. Using this with the On Overhangs Only feature is a great way to narrow down specific areas for support. Next, the section view works just as it does with the seam painting. It allows you to remove parts of your model to see areas that are difficult. Also, if you happen to paint something incorrectly and you want to start over, you can use this Erase All painting here, and it's going to remove any support painting that you've added. Let's move on to the filament and support section. If you have a multi-material system such as the ACE or the AMS, this option will allow you to use specific support materials when printing your models. For the most part, you'll never have an issue with using the same materials as the model you're printing with, but if you would like to experiment with support-specific materials, then you would select that filament here in the drop-down menus. Using different material for your supports will allow you to remove them easily. However, it's going to drastically increase your print time of your model. I've never had the need to use this feature. In an upcoming advanced video, I will talk about different settings that can be adjusted to give you some great results for support removal. Let's quickly go through the options in the Multimaterial tab. These are going to be for your multicolored prints. I'll be releasing a complete painting masterclass video for Orca very soon. So if you haven't already, make sure you're subscribed to my channel so you don't miss that. For now, let's enable the Prime Tower. Prime Towers are exactly what they sound like. Small towers printed alongside your model. Their job is to act as a purging station, clearing out any leftover filament from the nozzle before switching to a new color or material. Think of it like rinsing out a paintbrush before changing colors. This step is crucial for avoiding streaks, blobs, or color contamination on your prints. Now there are two key settings to adjust when using a prime tower. The width. This determines the size of the tower's base. A wider base provides more stability, especially for taller prints. Prime volume. This controls how much filament is purged during the color change to ensure clean transitions. If this value is set too low, you might see streaks or leftover filament from the previous color. On the flip side, setting it too high can lead to wasted filament. Start with a default value in OrcaSlicer and adjust based on your filament type. For example, PLA usually requires less prime volume, while materials like PETG or silk finishes may need more for smooth transitions. If you're unsure, start small and gradually fine-tune with test prints. Sometimes things don't go perfectly with prime towers. Let's cover a few common issues and how to resolve them. If the tower wobbles or falls over, try increasing the width setting to give it more stable base. For taller prints, turn on advanced mode and add a brim width. This creates a support ring around the tower, anchoring it to the build plate. For short prints, use the default brim of 3. Once you have a taller print, like a helmet for example, try a brim width of 8 or so. I would rather waste a little bit of brim filament than have a failed prime tower at 95% of a print. I see it all the time in Facebook groups. If you feel like the prime tower is using too much filament, try reducing the prime volume. Test with smaller prints to find the right balance between clean transitions and minimal waste. Tower placement. OrcaSlicer automatically places the tower in an optimal spot, but if it's too close to your model or causing nozzle travel issues, you can manually move it to a better location. Just keep it far enough to avoid contact with your prints, but close enough to reduce travel time. And there you have it. Prime towers may seem like a small feature, but they make a huge difference when printing multicolor prints. With these tips, you'll be able to fine-tune your prints and get flawless transitions every time. Flush into objects and fill. When you change filament colors, the printer needs to purge leftover filament to avoid color contamination. Instead of wasting that material in a purge tower, this option purges directly into the model's infill. This helps reduce filament waste and slightly speed up the print time while keeping color changes clean. Flush into object supports. Similar to the infill option, this setting purges filament into the support structures instead of external purge towers. This can be helpful if you have a lot of supports in your print, as it minimizes wasted filament and keeps the print process efficient. Both of these settings are great for multicolor printing when using an AMS or similar system, allowing you to reuse filament that would otherwise be discarded. Now with that said, let me show you one more tip before moving on. First, let me uncheck both Flush into Objects and Flush into Supports. Next, I will add a second Benchy model. Clicking on it and pressing Ctrl-C, then Ctrl-V to paste it. You can actually control individual models that have the Flush into Objects and Support features separately. So instead of wasting your filament on a prime tower, you can simply print an additional Benchy or toy or whatever you happen to be printing at that time. Just switch over to the Objects tab. Click on the Multimaterial tab if it isn't already highlighted. Next, check all three options here and all your flushing volume will be sent directly to this particular model only. Moving on to the Others tab, there are three different sections. Let's go ahead and start with the skirt section first. The skirt loops is one of those older print features that originally served two main purposes: filament priming and a filament barrier. If I set the skirt loops to 3, you'll notice that it will draw a barrier around the model before the print begins. This helped ensure the extruder was properly primed and ready to lay down filament smoothly. It also gave a clear visual where the print would be positioned onto the build plate. But with today's modern printers and slicing software, this feature has become somewhat unnecessary. Most printers now have a filament priming routine built right into the startup sequences, making skirt loops less relevant. In Orca Slicer, this feature isn't really needed anymore. That being said, some users still take advantage of the skirt height option to build a protective barrier around their prints. This can help in open frame printers where air drafts could affect materials like ABS, which are very sensitive to temperature changes. However, for most enclosed and well-ventilated printers, this feature has become outdated. Personally, I've never found a need to use skirts on my prints, so I'm going to go ahead and reset these settings back down to 0. Now let's go ahead and move on to the brim feature, which actually has a more practical use case. A brim is a great way to improve stability of your prints, especially for models with small contact points on the build plate. Think of a brim like the edge of a hat. It extends outward, providing extra support. In OrcaSlicer, a brim is a thin layer of material that prints around the base of your model to help with bed adhesion and prevent warping. Let's go ahead and select outer brim only and leave the brim width set to 5 and slice it. You can see that it generates a thin extension around the edge of your model. The brim feature serves two key purposes. First, it improves bed adhesion by helping it anchor your print to the bed, reducing the chances of it detaching mid-print. Second, it prevents warping by holding down the edges of your model, keeping them from curling up due to material shrinkage or temperature fluctuations. Warping is a common issue, especially with large, flat prints where the corners start peeling up from the build plate. Once you get more experience, you'll get a feel for when brims are necessary and when they're not. When I first started 3D printing, I used a brim on almost everything just as an extra peace of mind. And honestly, it was well worth it. Especially if you're like me and you tend to start long prints before heading to bed, using a brim can be the difference between waking up to a successful print or a complete failure. For me, that extra bit of bed adhesion is always worth it. If we take a look at the brim types, you'll see a default auto feature. This will automatically generate an outer and inner brim width calculation based on the model. This typically will be sufficient for most of your models when first starting out. Now you may have noticed with the auto brim feature turned on, after I hit slice, a brim wasn't added to the Benchy model. Now why is that? OrcaSlicer automatically analyzes each individual object and generates a brim with a proper width for it. It takes the following into consideration when generating the brim: the shape and orientation of the parts, filament type, and print speed. Let me show you a quick demonstration. Here are 6 rectangular objects on our build plate, all with different heights and widths. If I slice the plate with auto brim turned on, you'll see that OrcaSlicer generates a brim for the top 3 models, but none for the bottom 3. Based on Orca's calculation, the bottom models will not need a brim. However, the models on the top have a brim added, but for different purposes. This large cubic model has been given a brim because of the large flat surface area that it has against the build plate. The brim was added to prevent the corners from curling up or warping. However, you can see that these 2 skinny tall cubes do not have much area on the build plate. They are tall models, so the probability of a failure is at risk. The taller the print, the more likely you could experience the print detaching from the build plate and failing. Now, this is also much different when talking about the type of printer that you'll be using. A Core XY printer such as the Elegoo Centauri Carbon will be able to handle a taller print much easier than when using a rectilinear printer such as the Neptune 4 for instance. In my experience, I see more layer shifting and failed prints when comparing taller printed models. Now, I'm sure there are many out there that could argue this point, but I'm just speaking from my experience. It is honestly just the nature of the two printer designs. The next feature under Brim type is the mousier feature. Now, this is a newer feature in OrcaSlicer, and I honestly use it all the time. What the mousier feature does is place down little circles around your model in key areas to prevent the model from warping or coming loose. It does a great job by placing them automatically, and I've never had an issue, so it's a great beginner-friendly feature that will help you save a ton of time and headache. Take a look at how it places the ears at each of the corners of the models. The painted feature is directly connected to the Brim ear feature that we've already covered and went over earlier in this video. The outer, inner, and inner features are pretty simple to understand. The outer option will generate a brim on the outside edge of the model, while the inner option will generate a brim on the inner edge of the model. The outer and inner will generate a brim on both. The no brim feature will obviously turn off the brim feature. The special mode section has some really interesting features, so let's quickly go over them before moving on to the final section of this tutorial. One of the key options here is the print sequence, which determines how multiple objects on the build plate are printed. By default, this is set to by layer, meaning the printer will print all the objects at the same time, layer by layer. However, if we change this to by object, you'll notice that something's different. OrcaSlicer now generates a boundary around each of the models on the build plate. Instead of printing everything simultaneously, the printer will now complete one object entirely before moving on to the next. Now that we switch to by object, you'll see that both models have a protective ring around them. This ring indicates the area that each print will occupy, ensuring that the print head won't accidentally collide with the completed object while moving on to the next. However, if the objects are too close together, you'll get an error, just like we see here, telling us that the benchy is too close and may have a collision. This is definitely something to be mindful of when using this mode. So why would you want to print this way? One major advantage is filament efficiency in multicolor printing. If you're printing two models, each in a different color, the bi-layer option will force the printer to constantly swap filaments back and forth every time it changes the model. But with the by-object mode, the printer can finish one benchy model in white, then switch to the black filament for the other, eliminating the need for constant filament swaps and reducing wasted material. This feature is definitely on the advanced side, but it can be incredibly useful in the right situations. Whether you're working with multi-material prints or just want to minimize filament changes, understanding how bi-layer and bi-object works gives you more control over your prints. The spiral vase feature will be covered in a separate video. Basically what it does is hollow out your object and make adjustments to it. This feature is of course used for printing vases. The fuzzy skin is one of those features that I'm really excited about in OrcaSlicer 2.3. It adds a new way to create unique textures on the outer walls of your prints, giving them a more customized look. The original fuzzy skin feature was a great way for hiding print imperfections, but it worked by randomly shifting points on the outer wall of the model. The problem was that these shifts didn't connect smoothly between layers, which sometimes made layer lines even more noticeable instead of hiding them. With this new update, fuzzy skin now includes structured noise, which improves the appearance and gives you more control over your textured looks. Instead of using a completely random noise, this version lets you choose different noise patterns to create specific effects. Here are the new options. Purlin noise creates a smooth organic texture with natural looking variations. Billow noise, similar to Purlin but with a softer cloud effect. Rigid multifractal noise produces a rigid and marble-like texture great for unique surfaces. Varani generates a patchwork-like pattern by dividing the surface into irregular cells. The fuzzy skin feature in OrcaSlicer 2.3 gives you more control over where the texture is applied on your model as well. You can choose from 3 different options: contour, contour and hole, and all walls. Let's break them down. Contour. This option applies the fuzzy skin texture only to the outermost walls of your model. It leaves the inner walls and details smooth, making it a great choice for when you want to add texture to the outside while keeping the other surfaces clean. This is useful for models where the exterior needs to be rough or organic looking, like grips or handles on decorative pieces. Contour and hole. This setting does the same thing as contour, but also applies a fuzzy texture to the inside of any cutouts or holes in your model. If you have a model with windows, vents, or open sections, this option will give your inner edges the same rough texture as the outer walls. The all walls option This applies the fuzzy skin texture to every single vertical wall of your model, both inside and out. If you want a constant rough texture all over your print, this is the option that you choose. It's useful for prints where surface texture is important on all sides, like creating a grip or rough, weathered effect on the model. Each of these options lets you control how much fuzzy skin affects your print, depending on the look or functionality that you're going for. I went ahead and ran some test prints with all the different skin options and their default settings, and here are the results I got. It's actually pretty cool testing some of these settings to create some really unique textures for your prints. I urge you to give it a try for yourself. Before we move on from the Prepare tab, let's talk about the two green buttons in the upper right corner. The Slice Plate button gives you the ability to slice either just the current active plate or all the plates in your project. Since I tend to print large models, I almost always have multiple build plates open in my projects. Being able to slice all of them at once is a huge time saver. Once your plate is sliced, we need to decide on how we're going to get our print started. Now, depending on which printer manufacturer or model you're using, the pop-down menu that appears will look different. Let me show you a few examples. For the Elegoo Centauri Carbon, I have the option to print and export G-code. After I select print, I get a few different options in the pop-up menu. Switch to the Device tab after upload, and upload and print. I also have some additional settings like enable time-lapse, run bed leveling, and select which plate I'm using. Since the Centauri Carbon comes with a double-sided smooth and texture plate, I can choose the correct one before sending it to the printer. Once everything is set, I just hit upload and it sends the G-code directly to the printer. Now if I switch over to my Bambu Lab A1, reslice the model, and hit print plate, you'll see a very different pop-up window. This one gives me a full model overview, including estimate print time, filament usage, and even type of filament selected. It also allows me to switch to any of my other Bambu Lab printers without leaving the slicer window. Just note that you can only switch to the same model from this menu. For the A1, you'll see some additional options like flow dynamics calibration and enabling the AMS. Once you're satisfied with your options, just hit send to start the print. I'm going to go ahead and close out this window because when I changed over to the Bambu Lab printer, some additional options under the print plate button showed up. You can now see print plate, print all, send, send all, send to multi-device, and export options. It's pretty simple to remember what these do. The print option will start your print on your devices. The send option will upload the G-code to the device and hold it for printing later. And the export options will allow you to export and save the G-code to a USB or SD card. For the send to multi-device feature, you get a screen that looks just like this. It gives you a thumbnail of the model, time to print, and filament usage. You can choose to print either using the external spool on your printer or an AMS. Next, you can select which printers you'll be using by selecting them here. The options below will allow you to enable and disable printing options. The send options are there to safeguard your power system and prevent overloading. Instead of hitting print and sending your model to 10 different printers all at once and possibly overloading your power breakers, you can choose to only send to a specific number of printers at a time and allow a waiting period between each batch. So let's say you have 10 printers, but you only want to start printing to 2 at once. You would change the send to 2 printers at once and give it 10 minutes in between each batch. Once you're comfortable with your settings, you would just hit send. Now this feature only works with Bambu Lab printers currently, but I suspect we will see this feature become more compatible with every type of printer as OrcaSlicer continues to receive updates. Let's go ahead and switch back to the Centauri Carbon in the printer menu. Then I'll reslice the plate and hit print, select my options, and press upload. You'll see that the model is being uploaded to the printer in the bottom right corner, then it forwards me to the device tab after I hit send. This downloads my slice model directly to the printer through the IP address with no cloud services being used. Now in the device tab, we have this left-hand menu. This device tab is actually a web interface that is connected to the printer. So every printer will have its own device tab layout, but for the most part, they all kind of stick to a very similar design. For now, let's take a look at the Centauri Carbon's device tab. In this section here, you'll get an overview of the current print. It shows me an image of the model name, and print time, which layer it's currently printing on, percentage completed, remaining time, and the ability to pause and stop the print. Just below that is a control section where you can move the print bed up and down with these 2 buttons and home it as well. Next in the circular wheel, you can control the movement of the print head on the X and Y axis as well as homing it with these 3 buttons here. To the right of that is where you can see the current X, Y, and Z position of the print head, and just below that is where you can adjust how much movement you would like your print head to move every time you click one of these buttons. 0.1 millimeters, 1, 10, or 100 millimeters at a time. Just below that is where you can manually control all the printer's available fans. So for the Centauri Carbon, we have the model, the side fan, and the back fan control. You can also control the speed of the fans by hitting the plus and minus buttons here. Next to the fan control is the lighting control, and just above that is the print speed control. You have ludicrous, sport, balance, and silent. Below the control area is the file and print history of the printer. The file menu shows all the files that are currently saved onto the printer. Every time you send a print to the printer, it saves a copy just in case you ever want to reprint it. And that's actually pretty handy to remember. You get a list of file names, the size of the file, and how many layers it is, and the time it was saved to the printer. The material length doesn't look like it's currently working, but it would be nice to see that data for reference. In the Print History tab, you can see your past prints, the status of the print, when it was printed, and how long the print was, and file size. Looks like the file size isn't working currently, but I'm sure that'll get fixed eventually. In the next column to the right, you can monitor the print from the printer camera by hitting the play button here. Directly below that is the temperature control. You can manually adjust the nozzle and bed. This is useful for heating up your nozzle in case you get a clog and need to remove the filament from the extruder. Of course, you can always do that from the printer control panel as well. Now last, just below the temperature control is the menu where you can see the list of all the time lapses. The export feature downloads the selected time lapses directly to your computer. As you can see, this is a pretty handy page that allows you to control your printer without needing to jump into the control panel on the printer itself. Now that I've shown you the slicing feature in OrcaSlicer, I would like to go more in depth with it. Let's talk about what OrcaSlicer is actually doing when it's slicing your model. Just as you slice bread into pieces, OrcaSlicer cuts your model into thin horizontal layers. These layers guide your 3D printer on how to build your object layer by layer. OrcaSlicer divides a 3D model into horizontal layers based on the layer height that you have set, such as a 0.2 millimeter for standard prints. Each layer represents a cross-section of the model that the printer will create one by one. Think of it like stacking slices of bread to create a whole loaf. For each layer, OrcaSlicer generates paths for the printer's nozzle. It starts with the perimeter or the outside walls of each layer, which define the shape. Then it calculates the infill pattern and density to provide internal support. You can choose different patterns like grids, gyroid, or triangle infill patterns, just to name a few. Then adjust the density for the strength and material usage. It's like deciding how dense the bread should be inside each slice. OrcaSlicer also sets the print speed, adjusting it for different parts of the print. Slower speeds improve the quality, while faster speeds can be used for the infill to save time. It also sets the nozzle and bed temperatures based on the filament type that you're using, ensuring optimal adhesion and print quality. Then OrcaSlicer plans all non-printing moves called travel to minimize stringing and reduce print time. It optimizes this path to make the printing process as efficient as possible. Imagine planning the quickest route to spread peanut butter on a slice of bread without making a mess. OrcaSlicer calculates the flow rate of the filament to match the movement speed and path. It also manages retraction to prevent oozing and stringing when the nozzle moves between different parts of the print. Think of it as controlling the amount of dough coming out of the piping bag to ensure even coverage. Finally, OrcaSlicer translates all these plans into G-code as a series of instructions for your 3D printer. These instructions guide the printer's movement, extrusion, and temperature settings, ensuring that the model is built accurately layer by layer. Let's take this manta ray model for an example. We're going to slice it. Depending upon the speed of your computer, it's going to run through its slicing code and generate the G-code. Once it's complete, you'll be moved to the Preview tab. Now in the Preview tab, you'll be shown this overview window right here. I know it can be overwhelming at first, but once I explain everything to you, I think you'll be more comfortable. First up, let's start with the totals. You have the total filament, which include your model and any brims or supports. The totals will be displayed in both the length and the weight. Then you have the model filament, which only includes the total of your actual model itself. The cost total is only going to give you an accurate number once you set up a filament profile and set up the amount that you pay for each spool of filament. The prepare time is going to be the time that your printer takes to warm up and go through the bed leveling procedure. Model printing time is how long the actual print of your model is, and the total, of course, is going to be the combined time of both. Now, just above your totals is going to be all the different G-code movements of your printer. Everything is completely broken down into different commands, all color-coded and easy to follow. The yellow represents the inner wall creation, orange is the outer wall, red is the top surfaces, and so on. Each line type also displays the time, percent total of the entire print, used filament and length, and weight. The display option can be used to turn on and off each command for viewing. Next, let's quickly go over the drop-down menu. This is going to change the display of information in the window. There's line type, which is what we're currently on, filament speed, layer height, line width, flow, layer time log, fan speed, and temperature. Let's quickly run through each of these. The filament window is going to give you a much more detailed breakdown of the filament usage. This is especially beneficial when you have an AMS and you're using multiple types of filaments and colors. It's going to give you a clear breakdown of your usage. The speed window will show you a visual representation of your model and the speed at which we'll print each layer. As you can see on our man array model, the first layer and the brim are going to be laid down on the plate very slowly. This will give you better bed adhesion on the build plate. You can also see that the printer will start to slow down when it starts to print areas that are going to be an overhang. This allows the filament to cool in place as it slowly prints these areas. This prevents the filament from sagging as it prints these gradual angles. Layer height is only going to show us a single color because the entire model is being printed in a 0.2 millimeter layer height. You would see a difference in variation here if you had variable layer height turned on. This is a more advanced feature that I covered in Bambu Studio tutorials, so you can check that out if you like. Line width is going to be slightly noticeable with the difference in the brim compared to the model. You also see the line width variations through the print process. If you use this layer widget over here on the side, you can see the line width adjusting throughout the print process. You can adjust your line width settings in the Quality tab on the left side menu. For the most part, these options will stay the same. The flow menu is going to display the amount of filament used at a particular moment in the print process. This is called the volumetric flow rate. You can see that the model flow rate will have a range, indicated here in the menu. Layer time will break down the model into colorful pie slices representing the length of time to print that layer. The smaller the print area, the quicker it will be to print, and the more blue color that the layer will be. If I pull our layer widget all the way down to layer 1, you can see that that is by far the longest layer to print out of the entire model. The fan speed window will show you the change of the fan speed while printing the model. Our fan is set to 100% during the entire duration of the print, except for the first layer when it's turned off. So we have two colors in our menu, which is 100 and 0. During the first layer, the fan is turned off to give better bed adhesion to the build plate. Temperature is going to display the extruder temperature across the entire model. If your extruder changes temperature at any time during the print, you will see that in this window here. For the most part, you're going to see a solid color model just like this. Alright, that wraps up all the different slicing windows. I hope that these simple, quick explanations give you enough information to make you more comfortable with OrcaSlicer. Next up, I like to move on to the horizontal and vertical green bar. The green bar to the right is going to display the layers of your print. I call it the layer widget. The number on the top is going to be how many layers tall your print will be. The number just below that is going to be the height in millimeters. Now this layer widget is a great way to run through your entire print. You can move the circle with a plus up and down to display a particular print layer. This is good for times when you have a failed print happening at a specific layer. You will always be able to drill down to that point and investigate it. You can also hover your mouse over the entire bar and click, and the circle will jump to that position. At the bottom of the layer widget is another circle that you can actually move up to a specific area of your print if needed. Now the next feature I'm going to show you is a little advanced, but I think it's good to bring up so you understand that it's there. If you move the layer down just a little bit and right click, you're going to bring up a menu. Add a pause, add custom G-code, and jump to layer. The add a pause is one of the coolest features. This will pause your 3D print at the beginning of the layer. You may ask, why would you want to pause your print? With this pause feature, you can accomplish many different things. Here are two examples that I've recently used for the pause feature. You can pause your print to change your filament color. This is the most obvious. This is if you don't have an AMS and you would like to make a color change on your model. Now this isn't going to work very well if you're printing something that has like 100 different color changes in it. It's just not feasible, and you'll be sitting at your printer for hours on end. But for something more basic like two-color vase, where the base is one color and the top of the vase is a different color, that works perfectly. Another way to use the pause feature is when you would like to add something like a magnet or a metal rod for support to your print. I go over this in my Add a Magnet to Your 3D Print video. It's a very detailed tutorial that teaches you all the steps. The Add Custom G-code feature is a very advanced feature. This is where you have the ability to add custom commands to your print at a specific layer. So you may be wondering what you can actually accomplish with this custom G-code? Well, here's a quick example. Let's say you wanted to print multiple models, but you can only print one model at a time on your build plate. Well, now you can set the printer to push your model off of the build plate when it's complete and then start the next print. Now it's a lot more involved than the way I explained it, but I think you get the idea. The Jump to Layer button allows you to jump to a specific layer that you want to view. Type in the number and it'll take you right to that layer. The horizontal widget bar at the bottom is where you can view all the G-code created from slicing your model. The number on the right side is the number of G-code commands for that particular layer. Now the way this works is you move your layer widget to a specific layer. Then you use the G-code widget to scroll through all the G-code for that layer. you'll be able to see the order of how the entire layer is printed. This can seem pretty overwhelming, but the good news is you probably will never need to worry about this. Messing with the G-code is a very advanced feature. Now this little icon down here in the bottom right corner works just like a filter. It basically isolates everything except for the current layer so that you can see each layer individually if you want. It's a pretty cool little feature. Alright, that about wraps up the core basics of OrcaSlicer. But before we go, let's quickly run through a full process of importing and printing a 3D model. Back in the Prepare window, we'll start with a clean build plate. First, import your model by clicking on this button right here. Position it on the bed where you want it. I usually center it with the right-click menu. Then double check that your printer and build plate are set correctly. Next, choose your filament from the drop-down menu. Pick either a user preset or a system preset and set your desired quality and layer height. Make sure all the process settings are dialed in. Hit slice to generate your G-code, and finally, click print. That's it. You're officially on your way to printing hundreds of things that your significant other will definitely question. Trust me, I've been there. But seriously, this is an incredible hobby to be a part of. The 3D printing world is evolving fast, and there's always something new to learn and create. If you made it all the way to the end of this video, thank you. I really appreciate you spending the time to level up your skills with me. I put a ton of time into making these tutorials practical, straightforward, and grounded in real-world experience, and I'll keep doing just that. If you haven't already, I'd love you to subscribe to my channel. It helps a lot, and I'd be honored to have you along for the ride. Thanks again. My name is Nick. Have a great day, and as always, happy printing.